So Dijkstras algorithm, so I'm going to take now. So I think Dijkstras algorithm has not been solved, okay? So I'm going to give this information how to implement the Dijkstras algorithm. Dijkstras algorithm is a algorithm which is used to find out the what we can say single source shortest path problem. We can call this as a single source shortest path problem. So the problem what we have considered in our class. Problem what we have considered in our class. So I have a graph here. So the graph I'm going to write here. So you consider this graph. So this is the graph, and the adjacency matrix is also as like this. So this is the Dijkstras algorithm. So the graph is also, I have written it. So it is there, okay, in the syllabus. So that is the sixth problem. So I am going to see that. So this is the today's problems. from a given vertex in a weighted connected graph, find the shortest path to other vertices using Dijkstras algorithm. So this is what I wanted to implement today. So I'm going to share the screen now for implementation. I hope it is visible for all of you. The turbo screen is visible for all of you. I am hoping that, and continue. So this is the algorithm. So I am executing this now. So enter the number of nodes. So we have 6 nodes here. The matrix I have to enter 0, 15, 10, infinity, 45, infinity. We have infinity, 0, 15, infinity, 20, infinity. Then we have 20, infinity, 0, 20, infinity, again infinity. We have infinity, 10, infinity, 0, 35, infinity. Then we have 3 infinities. Then we have 30, 0. Then we have infinity again. Then 3 infinities. Then we have 4 and infinity and 0. So enter the source vertex, 0. So 0 is given 0. I'm going to give another time. 6 another matrix, 0, 15, and infinity. Then we have 45. Then we have infinity. Then we have infinity, 0, 15, infinity, 20, infinity. Then we have 20, infinity, 0, 20, infinity. We have infinity, 10, infinity, 0. Then we have 35 and infinity. We have 3 infinities. Then we have 30, 0, then again infinity. Then 3 infinities. Then we have 4 and infinity, then 0. 1 I will give instead of 0. So this is what the output we have obtained. Still there is a value infinity again. So let's just check this program at home. I'm going to share this program. So execute this program and check once. Okay, so next one, I'm going to take Kruskal's algorithm and the another minimum spanning tree, that is over, I suppose. Kruskal's algorithm, Prim's algorithm. So next, Washall's algorithm. So I'm going to take, because Washall's algorithm is used to find out the transitive closure. So I'm going to take that now. I hope topological sorting is also over. So that is why I am choosing this one. That is a binomial coefficient. Then we have Floyd's algorithm. Then we have knapsack problem. Then we have Prince algorithm. So Prince, first I will take Washall's algorithm is the first one I am going to take now. That is the transitive closure, I think. So it's here only I am going to take this graph, that is the Washall's algorithm. So I'm going to write a graph. This is Washall's algorithm. So this is used to find out the transitive closure. So we have A, we have B, we have C, then we have D. So in class also I have covered this. So the adjacency matrix for this graph is like this. It is a 4 cross 4 matrix. So A, B, C, D. So 0, 0, 0, 1, 0, 1, 0, 0, 0, 0, 1, 0, 1. So this is the input we have to take, and when we complete the process, the output is like this. Okay, so this will be the output. So all the values will become. So now you have to find out this through the program. So I'm going to execute this now. Okay, I hope this screen is visible for all of you, the turbo screen.
Visible, sir.
So it is the Washall's algorithm. I'm going to execute this now. So I'm going to give the adjacency matrix now. Since the 4 nodes are present, matrix of dimension 4 cross 4. So adjacency matrix is like this. So this is the adjacency matrix. I think so this is the adjacency matrix of the given graph. Now let us find out the transitive closure. So these are the different iteration 1, iteration 2, 3, 4. So at the end, this is the transitive closure 1, 1, 1, 1. all the values becomes 1. So this is called the transitive closure. Okay, that is the Washall's algorithm. So the graph is connected. Okay, so transitive closure has been obtained. So next we shall go for the next algorithm, Floyd's algorithm. Floyd's means all pairs shortest path problem. Okay, so this is also there in your syllabus. So I'm going to consider the Floyd's algorithm now. So it is Floyd's algorithm, also called as all pairs shortest path problem. So the graph what I am going to consider here is like this. So another example is also there in your textbook, in your notes. I have solved that. You can use that one also. I am using different here. So this is the graph. For this graph, this is the weighted graph, you know. So that is why the relevant cost adjacency matrix or weight matrix is like this. 4 cross 4 means 4 rows, 4 columns. So we have A, B, C, D. Of course, the principal diagonal is always 0. So this is infinity, this is 3, this is infinity, 2, 0, infinity, infinity, and infinity 7, 0, 1, 6, double infinity, 0. So this is the thing. Now, if you solve this, of course, the closest path what we have obtained, the output must be like this. So the output, the closest path will be 0, 10, 3, 4, 2, 0, 5, 6. Then we know 7, 7, 0, 1. Then we have 6, 16. We have 9 and 0. So this is the output what we are going to get when we execute this Floyd's algorithm. Let us find out how this will be done. So I am going to share that now. So now I'm going to take Floyd's algorithm. So this is the Floyd's algorithm. I'm going to execute this now. So we have 4 vertices in the graph. So 4 will be the next adjacency matrix, that is cost adjacency matrix. So 0, infinity, infinity, sorry, 3 I think. 3, and we have infinity, 2, 0, double infinity. Then we have infinity, we have 7, 0, and 1. Then we have 6, double infinity, and 0. So this is the input. So these are the different iterations. So we are going to make, and finally we have obtained this result. Okay, graph is connected. Output is connected. The graph is connected. 0, 10, 3, 4, 2, 0, 5, 6, 7, 9, 0, 1, and 6, 16, 9, 0 will be the output. So this completes your Floyd's algorithm. So next, the next algorithm I'm going to take now. Fine. Okay, so next we shall go to the binomial coefficient, because now from here onwards dynamic programming will comes into picture. So that is why I will go to dynamic programming now. And in the dynamic programming, if you take the first one is the binomial coefficient. I have solved some problems in the class. So like the binomial coefficient. So this is the one thing through which we can solve the NCK problems, that is NCK, and I have given the formula, so that is 1 and as well as C of n minus 1 comma k minus 1 and all those things. So that we have solved in our previous class. Okay, so directly I will go to the problem. See, if you consider this problem, that is 6C3. So this is what we have already solved. So the value of this particular problem, once we solve, we are going to get is 20. It is already I have solved this in my Dijkstras, and also I have given a problem for your the home. That is 6C6. 6C6. So this is the homework problem I have given, and the value for this one is 1. Because if this NCK, if n is equals to k, the output becomes always 1. So this is what the people already know about this. So I'm going to execute this binomial coefficient. So let us find out. We are going to obtain the same amount of results. So I'm going to take the binomial coefficient now. That is binom. I'm going to execute this compile. First I'm going to compile this. Then I'm going to execute this. The values for n and k. So first problem I have taken 6C3. 6C3. Once you execute this problem 6C3, you are going to get the result 20. So first value I have to give for n, that is 6, then 3 for k. So this is the triangle what we have seen while solving the problem also. So this is the value, that is the value NCK is 20. Similarly, if I am going to take the value for 6 and 6 for n and k, since n and k, if both are there equal, the value becomes 1. So the value is 1. So this completes your binomial coefficient. So next, I am going to take Washall's algorithm. Already I have given the information. So knapsack problem. Okay. So 0 by 1 knapsack. So that is a very important problem. We have solved a problem here on this. Okay. So I'm going to take the knapsack problem now. Dynamic programming knapsack problem. So this knapsack problem. So under this knapsack problem, you take, so we have a knapsack capacity that is m is equals to 5, and the table has been given. So item, weight, and value. So if you take the items 1, 2, 3, 4, corresponding values are 2, 1, 3, 2. No, let me check. But so values are 12, then we have 10, and we have 20, and we have 15. So when you solve this problem, okay, so for the using the dynamic programming concept, so V of n comma m is which is equals to V of 4 comma 5. We have already obtained 37. So let us find out whether we are going to get the same solution here also. This is an knapsack problem, and I'm going to compile. I'm going to run this. So enter the number of items, 4 items we have, and the weights of these items. First we have to give the weights 2, 1, 3, 2. 2, 1, 3, and profit 12, 10, 20, 15. Capacity of the knapsack that is 5. So 37 is the result we have obtained, and also in the problem what we have already solved also we have obtained the same result. This completes your knapsack problem. Okay. So the next one is backtracking and branch and bond. So in my next class on Monday I'm going to take backtracking and branch and bond. Okay, I will finish this as early as possible. Okay, so this completes my today's lab. Okay, so just I'm going to share all these programs in through the WhatsApp. So this completes today's lab. Okay, so I will share these programs after the meeting. So just use these programs and execute at home. Okay. So thank you so much for joining.
Thank you, sir.